Assalamu alaikum wa rahmatullahi wa barakatuh. So in the LCD tutorial, you have seen how to interface an LCD with the PIC18F4580 microcontroller. Now we'll be using this LCD module with PIC18F45K80 microcontroller to display the input values from some sensors. So it turns out that the XE8 compiler for PIC18F45K80 microcontroller, it does not compile, or it does not execute the sprintf function properly. So when you write this function and you try to execute it, the compiler, it compiles the program, but you will not be able to see the value of a copied properly to the string s here. So you may not see it properly in your simulation or in your LCD screen on the breadboard. So if it does not work for you, if the sprintf function does not work properly for you, what you can do is just comment out here, comment this function, comment this line, and instead of s, write EE366, EE366 using double quotation mark. You can write it here directly. Replace s with EE366 in double quotation mark, like how it is written here in double quotation mark microcontrollers. So that will display EE366 and microcontrollers in the two lines of the LCD. Now in the activity, connect the LDR, the light sensor, connect this to AN1 and use the ADC module to convert the analog input from the LDR to the digital equivalent, and use if statements to compare it with a threshold value and display on the LCD whether you have dim light or bright light. So in the example code, I have connected the LCD screen to port D register, and the RS and EN, they are connected. I have connected them on E0, -E0 and -E2. So in the LCD header file, you'll have to make these changes based on your hardware connection. So -E0, -E2, and the data pins connected on D4, D5, D6 and D7. So this is the simulation here. The light sensor is connected on AN1 and the LCD screen, VSS connected to the ground, VDD connected to the VDD here, VEE is connected to the ground, but on the hardware or on the breadboard, you'll have to connect a potentiometer to VEE. So it will not be like this. Instead of this, you'll have a potentiometer this way, and what we do is we connect one pin of the potentiometer to the power and another pin we connect it to the ground. So this pin the VEE pin is the contrast pin, and this will be connected to a potentiometer. So potentiometer, one of the pins is connected to the power, the other pin is connected to the ground, and the middle pin is connected to VEE. Then you have RS connected to RE0, RW connected to the ground, read and write. Since we are only writing to the LCD, so we never have to send a 1 to the LCD, so it's always connected to the ground. Then E, the enable pin, connected to RE2. Then you have the data pins D4, D5, D6 and D7 connected to RD4, RD5, RD6 and RD7. So let's play the simulation. Okay, so the light sensor, it takes input here on AN1, and you can see the voltage level on this pin is at the moment it's 1.32 volts, and this sensor is connected as a voltage divider. So you have a sensor here. The resistance of the sensor, it changes based on the input, based on the incident light, and there is a 5 kilo ohm resistor connected to the ground. So if I increase the light, so the voltage here, it keeps on increasing. So what is actually happening here is when I increase the light, the resistance of the LDR keeps on decreasing. So as the resistance here keeps on decreasing, the voltage here it keeps on increasing on this pin. So if I decrease the light, then the resistance here keeps on increasing, and the ratio here, it causes the input voltage on our AN1 pin to keep on decreasing. So at the moment it shows bright light when I have 1.4 volts here as the input, and if I keep on decreasing it, okay, now it has changed to dim light. You can see on the screen it has changed to a dim light now. So this is the schematic diagram, and this is the hardware connection for the breadboard. So you'll connect the MPLAB snap the same way as you have connected in the previous labs, and the LCD pins, the first pin is the ground pin, then you have VDD, then V0, VEE. Okay, in the schematic here I have not connected the potentiometers, so let's change it now again. Okay, so the first pin is connected to ground, the second pin connected to VDD, then the VEE pin connected to the potentiometer. So the potentiometer has one pin connected to power and the other pin connected to the ground. The center pin is connected to the VEE pin for the LCD. Then we have RS, which is connected to RE0 or pin number 8 of the microcontroller, and then we have RW connected to the ground. Then we have E enable, which is connected to RE2, which is pin number 10 of the microcontroller. Then we don't connect D0, D1, D2 and D3 because the LCD uses 4-bit data mode, and now we are connecting D4 to RD4 pin number 27, and then you have D5 to RD5 pin number 28, then you have 29 and 30. Then at the end, once again you have the power and ground for the backlight of the LCD. So this is the positive pin connected to the power, and the last pin is the ground pin connected to the ground here. Okay, so this is the connection of the breadboard, and you can download the program using MPLAB X. So in the main file we include the header file #include lcd.h, and since this is a user defined header file, we have to copy the file in the same folder as our project folder. So for example, if this is your project folder here, so we'll have the C file and the header file in the same folder. So copy it in the same folder and update the connections in the header file based on your hardware connection, based on the schematic diagram. And now I am initializing a new variable light where I'll store the ADC result for the input sensor. Oscillator control 60, which is 8 MHz, the default for 1418F45K80 microcontroller. Twist C, twist D, twist E, these are outputs. Twist A, I have one input which is RA1 or AN1, and AN1 is analog. So using the AN control 0 register, we configure this as analog pin. So one of the bits is 1, bit number 1. Initialize the LCD and clear the LCD, set cursor, initialize the ADC module, then start ADC conversion. So start ADC conversion by setting go bit AD control 0 bits dot go equal 1. So it will start the ADC conversion and then wait for this go bit to become 0. So this condition remains true as long as go bit is 1. So when go bit becomes 0, it will skip, it will go to the next instruction. So as long as go bit is 1, it will keep on executing this while loop, and this while loop does not have any body, so it will not execute anything. It will simply keep on checking this condition. So it will keep on checking this condition as long as go is 1, it will keep waiting here. So when go becomes 0, it will come to the next line and it will copy the AD result to the variable light. Now in C language, we can copy the high byte and the low byte together by simply writing AD result instead of writing AD result H and L separately. So if you write it separately, then it will only copy 8 bits. Now in this case, it's copying 16 bits directly to the 16-bit variable light. So I have declared this as an unsigned integer. So integer is a 16-bit variable, so it can store 16-bit numbers, and it can copy both the registers, the low byte and the high byte, together in this variable. Now I move the cursor to the second line, and this is a threshold value which I am just setting here randomly. So instead of setting this number, you can use a potentiometer, and you can dynamically set the threshold. So what you can do is, in your connection, you can connect a potentiometer on another analog pin. For example, say in 8, for example, you connect a potentiometer and you set the threshold level using the potentiometer. So what happens is, you take analog input, convert that to digital format from in 8 or from the potentiometer input, and compare the value of the potentiometer with the value from the light sensor. And if the light sensor value is greater than, if it is greater than the potentiometer value, then you can display dim light or bright light. And if the light sensor is less than the potentiometer value, then you can display dim light. So you can do something like that. In this activity, I have just set the threshold manually. So if the light is less than 1000, that means this 1000 is of course greater than 8 bits. So it's copied from both the registers together. So if it is less than 1000, then we write on the LCD dim light, and if it is greater than 1000, then we write on the LCD bright light. So if you have only one statement in the if or else, then you don't need the curly brackets. So I have written these curly brackets here. So these curly brackets are optional if you have a single statement to execute. If you have multiple statements, then of course you must have these curly brackets. But for single statements, there is no need for this. You can simply write it like this, and a simple delay of 500 millisecond before we close the while loop. So it keeps on executing this while loop, and it keeps on getting analog input, converts that to digital format, and copy the result to this variable, and then compares the result. If it is less than 1000, it keeps on writing dim light or bright light based on the amount of light. So this is the activity that you have to complete on the breadboard, and let us see the result now on the breadboard. So this is the hardware connection on the breadboard. The LDR is connected here. It is connected to AN1 pin of the microcontroller, and I have connected the 5K resistor, which is connected on the other side, to the ground. So one pin of the LDR is connected to the power, and the other pin is connected to AN1 input of the microcontroller, and the same pin is connected using the resistor, which is connected to the ground. And we have the LCD, it is connected, the RS pin connected on pin number 8, EN pin connected on pin number 10, and then on the other side we have the D4 D4, D5, D6 and D7 connected here. And the potentiometer is connected here. You can see the potentiometer is connected here on the back side behind the LM7805. It's connected here, and one pin is connected to the power, the other pin is connected to the ground, and the center pin is connected to the VEE of the LCD. So you can either use this male female jumper wires to connect the LCD directly like this, or you can connect the LCD on the breadboard. You can connect the LCD this way on the breadboard, and then you can connect jumper wires from this breadboard, from these points on the breadboard to the pins here on the microcontroller. So you can either connect jumper wires from here to this breadboard for the LCD, or we can use the male female jumper wires directly to connect it here like this. So this screen, it now shows bright light, and if I cover the LDR with my finger, it shows dim light. So this is how the program is executing, same as what we have seen in the simulation. So when there is light here on the LDR, it shows pure bright light, and if I cover it with my finger, it shows dim light. So it is comparing the analog input with the threshold value. So this is how the connection looks like. If you look at it from the top, you have the LDR here on AN1 pin, the other pin is connected to the power 5 volt, and the same pin is connected to the ground using the 5 kilo ohm resistor, and the LCD pins RS pin is here, pin number 8, then you have EN on pin number 10, and on this RD4 to RD7 you have the D4 to D7 pins of the LCD. So this is the LM7805 connected to the battery, and on the other side of the breadboard, this side, I have connected the potentiometer. So you may have to adjust the potentiometer. So using a simple screwdriver, you can adjust the value of the potentiometer to get a proper display on the LCD. So one pin of the potentiometer connected to the power, the other pin connected to the ground, and the center pin is connected to the VEE pin of the LCD, and you can use a screwdriver to adjust the value of the potentiometer to get the proper contrast for the LCD. So that's all for this lab. Complete the activity and submit it on the blackboard. Wassalamu alaikum wa rahmatullahi wa barakatuh.